All right. What's up, everybody? How's it going? Just took me a minute to get set up there. Sorry about that. I completely forgot to get a drink. So we're going to be doing a night coding session. It's that time here over on the East Coast. So tonight's going to be a little bit of fun. Wanted to get ready, wanted to get in the mood. We are going back to the original Nintendo. So this is the 8-bit NES. This is a kind of interesting machine, retro, magical, wonderful, fun, surprisingly low cost at the time, considering especially how much hardware it has. Now, we're going to be trying to get it to act somewhat like a modern game. So for those of you who don't know 88-bit music, and I'll drop a shout out there for the 88-bit music because I didn't turn the bot on because it's just gonna be one of those things. Anyway, I'll just I got a better idea. I'll just give you a link to his his stream myself. So this is a composer / piano performer who's really, really talented, specializes in video game music. And I caught him one day when he was busy doing, on one of his alerts, he has this kind of Toto Africa alert, where he puts a game cartridge into a Nintendo. And I was like, we could make that a real thing. And he was kind of like, no, I've got this thing in video game. I think he used, Video Game Maker. I'm not 100% sure. Or GameMaker Studio, that's what it's called. Which he used to build, a game that you could play in chat. And he used a scene from that in the actual alert. And I was like, why don't we put that on a real Nintendo cartridge? And I think he thought I was kidding at the time, but I'm not kidding. And tonight we're going to do the needful. We are going to get that cartridge. We're not going to build it on the cartridge tonight, but we're going to be working on building the game that we're going to burn onto the cartridge. And what I was showing you earlier was one of the test proms that I was messing around with to actually build a video game. So this is, so the goal here is to eventually get, and hey, it's BMO. What's up, dude? How you doing, BMO? Thanks for the subscription. I appreciate it. We're going to be going for hardware. So we're going to be trying to get on a chip. We're not going to be doing the chip tonight. You don't get to all laugh at my horrible soldering skills. That's something that'll be coming at some point in the future. But tonight we're going to be in the emulator. We're going to be doing the software side of it. And so I have not tried streaming NES stuff before, so I think we're going to have a little fun figuring out if the emulator gets on the screen. So chat, definitely let me know if I start referring to a window and you can't see it. Tell me, okay? Just let me know, because I just quickly set the scene up, and we'll find out what happens there. So this is our coding screen, and I've got 88-bit music because I was just getting that link, and I pulled up, for those of you who haven't seen it before, if you ever want to do anything really serious with the Nintendo, you probably want to look at the Nes Dev Wiki. It is a fantastic resource on the hardware. There's a lot of forums. It's a little harder to get the data out of there. People have sort of mined that and put it in the wiki. So I pulled up the page for the PPU, which is kind of the early GPU for the Nintendo. This is the picture processing unit. So we're going to be bit banging on the PPU. That's how we're going to get the graphics to happen. And to get this kind of started, I began with something I'm going to refer to quite a bit, which is Shiru. So Shiru built a C example program of using the PPU, which is pretty cool. It's nice. He's got some nice tutorials. I put it in the public domain. I should really dig a link up and put that over here. But and yes, Sonny, we are going to be singing. That's that. If you haven't seen the alert, treat yourself. Go on to 88-bit music. He has it tied up to a specific donation alert, so you can. He's like completely overproduced this video where he's got pixel goodness all over the place. It's just really, really funny. Really, really funny alert. So yeah, so tonight we're going to be using Messen, which is a pretty solid emulator. I did some sample code sort of before this stream just to kind of get things started. This was really about like, there's a bunch of issues with the Shiru code and the modern version. So we're going to be using the Cc65 compiler, which is thankfully in my in my path right now. Cc65 is a C compiler for the 6502, and this covers a whole bunch of different 6502 based systems. So you can compile for the Apple IIe, you can compile for Commodores, you can compile for the Atari, you can compile for it lets you target all sorts of different systems, but the support for the specific hardware it depends on like which one you're running. I mean, like they have something that builds for everything, but it's mostly like kind of aimed at like a text-based console, which is not at all what we're going for tonight. And hey, what's up, Fafi? How are you doing? And by the way, Sonny, I haven't seen you in a little while, so it's good to see you again. I haven't seen the characters in the chat room. So yeah, we're gonna be going down. We're gonna be blessing the rains down in Africa. So. Most of the magic is going to be here in main. So I lightly adapted some of the code that's in there, and I just did some background work because some of this stuff's not really super documented. So, but I mean, Shiro did. I mean, it's amazing that Shiro was able to put all this stuff together and post it. So I'm not criticizing that. It's some of it hasn't. It hasn't been kept up to date. So most of it compiled against a version of Cc65 that's several years old. And most of my pre-work was really just getting this CRT0 thing to compile, because this is now somewhat incorporated in the Nes lib, which is included with Cc65. Unfortunately, it was missing a bunch of routines, in particular the video update stuff. So if you want to, we'll have to get a little bit into how the NES works to go down there. But basically, you kind of want the version that Shiru had or the version that Nes Doug derived from Shiru. So most of the pre-work was really around that. It's not terribly interesting. I just took a basic, so I just mentioned like, yeah, this is from Shiru. And this is a linker script. You have to get the stuff assembled in the right fashion to fit into a Nintendo ROM. And that means you have to be very explicit. If you're not aware, like, a modern executable is, like here, let's just pick something like ls, right? So if I go and I look at something like this, and this has a bunch of metadata associated with it, which is not at all what you can include on a regular Nintendo. So this is a dynamic link executable, so it's going to pull in a bunch of dynamic libraries, which the Nintendo doesn't have. This is how it's going to get linked at runtime. This is some extra metadata, and this is the debugging stuff was stripped. You're definitely going to strip the debugging. It's in ELF format, and this is targeting 64-bit executable. So that's the machine I'm running on. But when you're talking about a 6502, you basically have none of that. So the loader is like really, I mean, the system basically has nothing in terms of ROM. I mean, it just starts executing, and you have to sort of like bring the computer into a stable environment. You're sort of responsible for the boot, which Shiru's lib handles. There's some NES stuff that's available that'll help do that for you. Elf was a good movie. Nice. You haven't streamed much. That's not true, Sonny. I have streamed much. I stream every Monday. Well, yeah, those are the learning sessions. Yeah, I was a little irregular last. All right. I'll give it to Sonny for now. But Sonny, I'm just trying to say that I miss you. That's all. So anyway, you have to be explicit about how you want this executable to get assembled. It's not just a matter of emitting 6502 assembly. You need that 6502 assembly to go into the right order, because the Nintendo cartridge, and this is one of the ones I destroyed when I was kind of putting this together. This typically has, I don't know how much of this I can say without getting DMCA'd, but anyway, maybe somebody else is talking. I don't know. This is the CIC, the SIC chip, the Nes Lockout Chip. And you've seen that before if you used a Nintendo and you notice like it was like blinking, you know, when you turn the game on. That's because something went wrong with SICK. That's a copy protection. And then a lot of the cartridges sort of differ. This is the memory mapper here. This is a very, very basic one, which is kind of a null one. And then these two are the character data. So that's going to be the tiles that we're going to display on the screen, and the program data, which is what we're going to execute. So you have to get that to link properly. And that's kind of what you're seeing here in this linker script. So this is just, and this is fairly boilerplate, so I'm not going to go into like how all this works. You can pull this. This one was modified from Shiru and the one that's included in Cc65. The new Twitch UI sucks. Also, you've streamed twice in the past 2 weeks. That's now a lot. Not a lot. Okay, well, all right. Sonny's going to give me a hard time, but so this is basically just saying that the 0 page in memory is going to start at 0 and it's going to go to 100. These are hex offsets. There's some other stuff that's going on here. Here's where the program ROM is. Here's where the character ROM is. This is going to be RAM. So these are all kind of mapped. I lightly modified the Shiru stuff just to get it to work. I mean, I didn't try reorganizing this thing. Like I did change where the stack size is based on how much I want to allocate for stack. I don't want to be too stack heavy. And we are using a particular mapper. So this is where the mapper, and that corresponds to that this chip. So when it's assembling the ROM, that's going to tell like the emulator like this is an MMC1 or an MMC3 or, you know, whatever particular memory mapper you're going to be using. Yeah, I had to just kind of like this was in this older format where when Shiru did this, like you didn't have to specify anything else other than the address where to start. You now have to specify some other stuff to get it to link up correctly. So there's a lot of fun stuff just to getting to something that builds, which is fun, and in the fun sense of not fun. So where we are now, I saved you all that trouble. So we can do make, we can make clean, and we can make, and we're good. So we end up with an executable, which is right here, this test NES, and I've got it designed for really low chip requirements. And so we're gonna try to stay as low as we can. If we need more graphics memory, then we'll probably bump up the character. But you know, again, that's gonna relate to like what kind of chips we can use and what type of mapper we have to use. So we're gonna need a donor cartridge to do that. And so anyway, this is not a ton of space, but it's a lot in the NES sense, but can you go back to Python? No, Sonny. You keep saying that Python is just way too simple of a language. So here we are on a much harder language. we're literally like just assembling like everything, like from the assembly standpoint. Hey, what's up, Opti? Haven't seen you in a while. Sonny loves Python. Yeah, we know how much Sonny loves Python. So, all right. So where we're at, I just started adding the notion of a state, sort of a simple state machine to say what mode the game is in. Because keep in mind, in your game loop, you're just sort of running, like I'm just using a single game loop. So here I'm just saying like, okay, you're in the attract screen because the title screen, because it just loaded. We're actually running a level, or we're doing some sort of loading. I don't know if we're really going to bother with this. I kind of want it to prevent keyboard to keypad input, you know, while we're busy setting up the name table for the next screen or whatever. So for right now, I just kept a really simple level. I haven't written most of this stuff. One of the things that's really kind of tricky here was figuring, so I just started adding randomization. I haven't really gotten that far. Is this line right here. And RLE is run length encoding. So this is, there's a format Shiru wrote of RLE, which is not what I thought it was going to be. And it's not the same as what I showed on stream when I did run length encoding during the streaming, building streaming from scratch. So it took me a little while to kind of figure this out. I ended up just sort of modifying the program that he had for building tile maps, and I extracted it. So let me just pull, I don't think I included that here. So let me just, yeah, I didn't. Okay. So I'll just pull that up, which is over here in one of these places. So I had a, yeah, Structify. Okay, Sunny wants some Python. I have some Python here, actually. This is some very boring Python for Sunny, but we know how she does approve. So yeah, this is in here. So let me just copy this, because we're going to need to structify some stuff. So this is Structify. This is your Python, Sunny. I used pill and numpy to very quickly pull in the title image that I wanted to use and just turn it into an array and just rip through this thing and just say, hey, every time the third value, which is the alpha, turns out to be 255, then emit a 1, otherwise don't. So there you go. Sunny, I hope you're happy. You got some Python. We're not going to be doing much Python tonight though. So anyway, when you do that, you end up getting this kind of messy hex values, which I then run length encode using the funny program that we're going to need that. Of course, I don't know what I did with it. Well, that's, if you're kind of curious, this is what it looks like when you pull up the raw image that I was just sort of messing around with. So here's Structify, and yeah, all it is some alpha value, so you can see nothing. But it's the right size. It's 32 by 16. All right, so we come in here and we find our, oh, you know what? I know where I tucked it. Of course, I called it test.c because I had no idea how this was going to work. So let me just copy that so you could just take a look. It's not terribly interesting. I just based it on Shiru's, yeah, test.c. So I based this on Shiru's run length encoder. So this is, he has this NES, I forget what it stands for. It's like sprite tile, I don't know, tile maker or something like that. Anyway, he has a file in there. It's all public domain. And basically you pass it a character array and how long it is, because it's not going to be null terminated because null is a valid bytes, but this is basically just raw bytes. And it emits for you in the right run length encoder format that Shiru expects for the assembly decoder in there. And this is the raw data from that Python script that you just saw. So I just took that and slapped it in here because that's what the Python emits. And then I come out and I run length encode it very, very simply. I just, it took me a little while to figure out how long that it was returned. So, yeah, it just prints out the hex, which is what I dumped over in this other file. Oops. So that's here in data. Yeah. Okay. So when you do that, it run length encodes to be just about exactly the same length. So I feel like we won almost nothing from figuring out how to get that run length encoding to work. But oh. Hey, what's up, Nightshade dude? How's it going? What's up, Opti? Yeah. Anxiety too. Chilling. Dual streaming and coding. Wow. Opti, you're a monster. What are you? That's nuts. And Nightshade dude, enjoy dinner. I was so happy I finally had a burger. It's been a while. All right, so we get that stuff into a ROM, and I'll show you where we are right now. So we do our make. And I'm just, by the way, just pulling the the raw Cc65 files for the Nintendo include Long Branch and the Nes Lib. Now, I ended up not using this. I was trying to use just the stuff that was built into Cc65, but I ended up using the CRT, which is kind of its own. The Nes Lib is basically the same thing as CRT. And then what I do is I compile the C program, which actually turns it does not turn it into an object file, it turns it into assembly. So this is your output from the when you run Cc65. It does not give you an object file. It just, here's all the references that it's going to refer to, and here's the data, which is mostly that run length and code that I just showed you. And wow, now we're doing assembly. This is like a whole other level to be doing on on Twitch. But yeah, and you'll see, like, you know, it's emitting also the source that corresponds to the assembly chunks that are kind of here. So we're not going to be directly doing much assembly tonight. I expect we're mostly going to be in the C domain. But you then take that and you basically assemble it with Cc65 to compile it from C to assembly. You end up with main.s, and then Ca65 to take it from assembly to object file, which is what's, you know, showing up here. And then you have to go through that linker script with the other stuff. So you need, you know, CRT, and you need a copy of Nes Lib and whatever, and then it puts it together into this ROM format. So Fafi's saying, so are you going to be building a game for the NES? Yes, Fafi. And in fact, we just built one, because I'll just, you know what, I'll build it for you, Fafi. Let's make it. There it is. This is a game for the NES. Now we can look at test.nes, and this is a Nintendo Entertainment System ROM image. Here's the iNES mapper. This is the header information. We're gonna have to strip that information off when we actually put it onto a real hardware cartridge. I had a lobster quesadilla, so good. Nice up. Yeah, I haven't had lobster in a while. All right, so right, we're going to get into this code as we sort of start progressing. But let me just show you where we are, sort of as our starting point. So I got all that stuff to work, and we run this, and theoretically you're going to see a window pop up. Yeah, here we go. Man, the amount of work off stream to get to this point. So I just popped this up. I'm using Pico Edit, the Pico, what's it called? Pico Pixel, to do, this is Pico Pixel, yeah. So I'm using this to do the graphics that I'm bringing over here. I did extract the source material. I mean, so basically, I mean, so Trevor originally had written a game in like 1920, you know, like in really high res, you know, something that would be like, you know, streaming format. This, you got to knock it down to get it to run on an NES. You have like 256 by like 240, I think. Like it's actually, it's gonna be here in the, oh yeah, okay. So yeah, you have 262 scan lines, but a bunch of those are not available. It's the V blank interval when you're, you know, sort of off the bottom. And yeah, then you get this per line. And so when you do that, you end up with this kind of thing. Nice. So that'll be our first sip. So I haven't gone too far in this. This is mainly just trying to get the attract screen to work, and I started polling the joystick. So this is the joystick. I do no collision detection, so we're not doing bounds. We're just going anywhere we want. And I added a basic shot just so that I could say in the code that, so this is my jump routine, you know, kind of, we're going to need to add gravity and that stuff. But yeah, this is the, and we have a projectile so that we can say shots fired. So I added a few slurps here. So this is kind of our monster boss that we're going to have to build. And for those of you who haven't seen it, actually, you know what? We should really take a look at that, which is, this is the original game that I was shown.
But see, when people try to sabotage by turning you around, you can counter sabotage by backflipping. If you just go to the left, you can get those bits. Go to the left, you can get those bits.
Yeah, let's start that over.
When people try to sabotage by turning you around, you can
Okay, so we have some platforms here.
If you just go to the left,
this is the bits that he's talking about. You need to get a certain number of bits to open up the door. There's no scrolling.
You have an entire minute.
By the way, they're controlling this by chat, which is, you know, kind of cool. And so the idea is, like, so we're going to need to add a little bit of geometry so that we can jump. So you jump up.
He can't walk upstairs. He has to jump.
They've got it jumping while it's in air if the command comes in. I don't know if we're going to get to the moving platform. That's a little bit of a stretch goal. And then you can walk off, and then it, you know, basically starts the next screen. Now, he's keeping the score up here, and he's also got the time remaining on the level. I guess this is how many times you've been hit. So here we have some monsters. These are the Schlorp monsters. I don't know what they're called. And he shoots notes. So we gotta change our projectile to that, you know, to do the this note here that you can see. So right now I just use the basic block because I didn't really have it like set up, but you know, that's kind of where we're going with that. All right, well, let's get to work. So this is, so PicoPixel does have this has a copy of the graphics that I'm using. So I'll just do this, pop open something. So yeah, we can close this up. And I'll drag this over so you can see it. So yeah, this is the drawing that I did. So you can see it's really high-end artwork here. And this just basically lets you like tap out the pixels. And so what I did was I took this, brought it into that Python script, and then I, you know, turned that into a C struct basically, except I used that RLE in order to be able to get it like onto the actual game. All right, so yeah, that's kind of what. So there's our graphics process. I'll show you really quickly. This is the Bitboi that I had. So this is what I've just stacked a bunch of these together because at first I thought this is 8x8. And at first I thought that we had to have our entire character fit into one 8x8 sprite. This is the size of a single sprite. But it turns out, just like Super Mario, what usually gets done on the NES is you stack like a bunch of these sort of together. Like, you know, you can kind of put like one here, one here, one here, one here, one here. So this group of 6 is sort of like Super Mario. So we're not going to save that, but anyway, that's kind of what I'm using to move the, you know, to move the thing around. So I'll show you that over here in the code. And that's actually, we need our NES stuff. So that part that I just referred to is right here. So I've got, I'm using the OAM sprite hardware, and I just basically start writing out the sprite, you know, from where you want it. So this part, I'm going to show you in a moment. This is basically like I told you before, there's those 2 chips on the Nintendo. I mean, it's not every game, but most games. And the program is running on one. The other one has the character graphics. So this is sort of like the offset on the character graphics for which tile you want to display. So you put all your graphics onto that character table. You can actually have the CPU write that directly if you want, but in this case, I've done the character graphics in advance. So they're written out onto that character ROM, and then we assemble this onto the screen. So here I'm using the same tile for all of these. These are all tile 80. But we're just putting them kind of next to each other. So we start here on the top left, you know, so this is just wherever the sprite X and Y are. And then we add 8. So this is the next one over to the right. And then we do one line down, so one line down, and then we do down and over to the right, and then we do down 2, and then we do down 2 and over to the right. So that's our group of 6. So we can just move this sprite and we basically end up with our character moving. And that's what I tied to the game stuff. So this is my very, very simplistic joystick handler. So in this routine, you basically have to bit bang this. I actually did an entire episode on the data format of the NES, so you could read all about that later. But this pad pull routine basically just reads all of the bits. You have to cycle the bits and read in, like, there's 8 buttons on the NES controller, so you read them in order. And this does that, and then you can and it with whatever, if you want to test, like, for a particular direction. It's like, if they pressed left, then, knock 2 off the sprite location. If they pressed right, add 2 to the sprite location. This is very, very simplistic. This needed the state machine, right? So we need to be able to say, like, you're on the title screen, so don't move the sprites, like, if you're in the game, then actually go around to that. So I just bound select for moving between these things. So for right now, I just added this fictitious next level. So we're going to kind of do that. That's kind of where we're heading. C Python assembly. Just have to throw JS in there for good measure. Nice, Fafi. Sorry. Yeah, we can do that. We can get some JavaScript in there if you need it. All right. So, yeah, let's fire up some coding music here. So I'll just play this stuff. Let me know if this is too loud. Kind of keep this down. All right. So I think the first order of business is we don't want this handler to happen all the time. Like, so right now we have this main loop. And there's just one universal main loop for the entire program. So we should probably make this a little more mode sensitive. So if you're on the start screen, we're gonna probably have a couple options. So I guess we'll do something like press A to start. So yeah, for now, let's just say whether or not you're on the track screen. So this is sort of where we started. So we have our game mode, and I don't think I used this anywhere yet. Yeah. Okay. So if game mode is track, I'm not too worried about being super efficient with the code on the first pass. More worried about let's get this to let's get this to run. So there's some of this stuff we're not going to want to do on every cycle of the loop. So for now, let's just say if you're in the attract mode, then we should probably start breaking this apart, actually. So if you're in the attract mode, then all right, so this is all of this stuff is actually related to, yeah, this is all game. Okay, we're not actually going to need, I kept frame around just for debugging purposes, but we can start pulling this stuff out. So one of the things we're going to do a lot on the Nintendo is we're going to use a lot of global variables because there's only 1.5K of RAM. So we don't have much space that each function is going to have its own like memory stuff. But I'll see how far I can get with like using a single function. But all right, so let's dump this here and basically call this the play loop. I mean, so like we would break this into separate loops. That way we don't have to do the if conditional every time, but whatever. Let's just start simple. So this is game mode. Actually, just split this real quick. All right, so this is, we're gonna do the level mode. Do level. There you go. All right, it's not going to take anything, and we're good to go. All right, so that way we can avoid being too far indented. There's going to be a lot of like ugly code here, so I'm just warning you now. Okay, so this will be, so load level, I'm just loading up the initial attract screen. Here we're saying then do level. We could implement this as a go-to or something like that. I'm not that worried yet. When we start worrying about speed, we'll, I guess, you know, with a Nintendo you always have to be a little worried about it. But so for right now, let's just, yeah, let's do nothing. We'll just do a, we'll do a quick poll. So we'll just poll to see what the controller's doing, and if it's, we'll just assume there's a single option. So if the person pressed A, then we'll change modes. So actually, I already have that as select, so let's keep the same debug workaround. I mean, it's probably going to be like A in a real game. So this will be game mode goes to level. All right, so this happens once, and then we're kind of in our do level. Now, what we could do is we can make these like just loop themselves. That way we don't have to put them into one mega game loop. But I think for now, let's just stay simple. Now, when I pulled all that stuff up here, I need to move all these variables that it's using. So I think, yeah, see, this is where you get into trouble. With memory, right? You know, like we could reuse that if we just pull it up as a global. So that's what we're going to do. All right, and then I forget what I was doing with next level. Yeah, it's not really that big a deal, is it? So let's just pull that one. We don't need next level down here either. But this doesn't really need to be global because we can just do that here. And I take that back because we want the other system to be able to change it. Yeah, and you know, we can start seeing some compile errors. Yeah, so we don't have sprite X and Y and all that other stuff. So let's take those, shot fired, and the sprite graphics. So let's just move that up here. And we need frame tile and SPR. Except SPR is something else. Oops. So this doesn't matter until you're actually, I'm using this, you have to draw the sprites, you have to know which index you're on for each sprite. So you draw a sprite and then it sort of tells you, and then you just keep moving the offset up in the sprite hardware. So it's like, I'm moving sprite 3, I'm moving sprite 4, you know, so on. So this doesn't need to be in the main game loop anymore. So we can do that here. Actually, we can do that on assignment. Now, we don't really need that to be on the stack either, but I just want to check to make sure that we don't have any other reference to it. Yeah, okay, we don't. So let's just pull this up here. And this is kind of like the current sprite. I was trying to build Snake in C# and having trouble figuring out how to show the tail properly. Yeah, that sounds like fun, debugging. So, all right, yeah, so this is kind of like where I'm moving, you know, each of these, uses which sprite offset you're on. So it's like sprite offset 0, and then it returns the next sprite. So I think it's like increasing by 4 each time. So, and then you pass in the next one, and then, you know, it's like 4 bytes for each sprite data structure. So, so that's kind of like, we're just using that to get all of the stuff to be on different sprite. You have 64 hardware sprites. There's a limit of like 8 that can show up on a line at a time. So we're gonna have to be careful about that. But all right, so this was just a very silly animation loop that I had, but I was just showing that the I don't even think I use this anymore, to be honest. So let's pull that up here. Oh, I do have a reference. Oh, right. So yeah, that's not a big deal. We can just. Thank you, Panera. Wonderful music. All right, so we can keep track of our current frame here. That'll be nice for debugging, and we can take a look at tile. So this is just which active tile I'm writing. This was to show a very simple walking animation, and I was just basically using it so that every 5 frames. This is really debugging stuff, so we're not really gonna do it this way, but I'm now using the sprite hardware. At the time I was messing around on the name table. Okay, so let me get the tile, which is here, and we'll pull that up as well. All right, yeah, and then this stuff happens in here, so we get back to a working build. Let's, well, it builds at least. Let's run it. Okay, so we do this, and we hit select, and nice. All right, so now we have a modal thing. Now, our performance got kind of nasty, and I'm resetting the position every time. There's my... All right, so I'm not keeping the position state right now, so we need to reset that. Slight refactor bug. So that's, yeah, that's basically this. Actually, you know, we're gonna have the same problem with the shot fired too. Everything else is working, just the tail. I don't know how you got yourself into that one, Foffy. I mean, why would the tail be any different from any other part of the snake? And look at that, we can now move. Now you'll notice there's a little more tearing. That's probably because we're doing more stack stuff now than we were. Actually, yeah, it's not bad. Yeah, it's tearing. Something wrong with up. All right, and probably, yeah, my shot still works. Now, it's funny because every time I press shot, I'm pressing and holding, it starts the shot over again because there's only a single shot sprite. So we gotta fix that too. All right, so let's start with that one. So our basic problem here is we're not looking at whether or not the shot has been fired already. So this is on when I'm pressing B and shot fired. Actually, I guess it's not shot fired. So that'll start it, but it has no way to end. So this will make it so we only have one shot that could ever be fired. So I guess we just need a reset there, like if we're off the end. Yeah, so here's the shot update. Otherwise, oh no, I did already reset. All right, cool. Let's see how that does things. Oh. Yeah, get out of here, emulator. Okay. Yeah, no, I can't shoot more than once. All right, I mean, we'll have to cap that with like, oh, and I have to wrap around there too. But, so we'll need to set that up. We'll need to like have a limit on like the number of shot sprites we allow. Let's just start with like single shots, enough for this. Right. So this thing needs to turn into a musical note. So yeah, let's add that musical note in. So I'm going to show you something kind of fun there, which is I guess we can get the 3 music. Nice. So yeah, the way I did this was somebody, Trevor actually posted this game on itch.io and itch.io, and I actually went and found the graphics. I'm not going to say how, but anyway, so there's a source material directory here. Yeah, which has a whole bunch of textures in it, and that's here. Okay, and so I just sort of plucked a bunch that I thought might be applicable. So let's take a look at that. So here's, I'm just gonna pull this up in the browser so we can see what we're into here. Oh, because the tail grows, so its position is offset from the head. That makes sense. Yeah, in fact, you kind of have to remember where the snake traveled to, right? Because it, like, if you move and then it gets longer, like they all have to follow. I mean, I haven't built an actual snake game, so I'm just guessing that's like part of the fun. There's some simple hack for it. Not because it's simple, but just because it's worked on such low memory systems before, like the NES. So found, yeah, Nightshade, dude. I just found them, and they all just happen to be the same names that I guess Trevor named them. I don't know how that happened, but anyway, so yeah, look at that. Look at, there's a note. So now you can kind of see the edge of this, which is sort of the issue. This is 100 by 100, so I mean, this would be huge in NES terms. So I've just been redrawing the graphics, not to mention the fact that we have the palette limitations. So let's just do a quick musical note here. I'm gonna close up Bitboi, and we can all suffer together pixeling. There's some great pixel artists in the world, and there's me. Okay, so we're gonna pull this over to here, which is this thing. Oh, of course it wants to go off screen on this. Yeah, it really doesn't like my Windows setup, so I'm just going to close this. No, don't save that. All right, run. I'm just gonna say picopixel here. Oh, we got to give this a size. So let's make this 8 by 8. And move that over here. All right, so let's get our sampler set up. And source material here. Oh, actually, you know, this might be better. Oh yeah, there, that's basically what we have to end up with. Alright, so nice NES sound effects here. And you have a smudge of terribleness. All right, so I guess this comes down. Yeah, you really don't want that there, do you? I mean, that's not terrible. Does that give it too much heft? I guess this is our preview here, what it'll look like. But that's still pretty zoomed in. Fafi says yes. All right, the other thing we can do is, I guess this is supposed to be baselined. So we could move this up. Oh yeah, that makes it way more musical notey. But the tail here is actually kind of long. Oops. Is that better? No, it looks like a shoe. Yeah, that kind of smudges it too much, I think. That might be better. Huh. No, I'm definitely not sold on that pixel. All right, so I guess we could pull it. Nah, that's going too far. All right, so there's our musical note. Oops. Just grab that real fast. Give me 1 second, stream. All right. Yeah, I just spilled some wine, which is not too cool, but I think I got the worst of it. Mainly, I'm very worried because now there's no wine. All right. Okay, so we've got our musical note and we have less wine. All right, so let's go back to our normal view. And not that. So let's go back to here. All right, so great. We have a note. We have to get it into party foul. Totally. Nightshade dude, totally party foul. Okay. So I have to drink for that. Okay, so how do we get that into the game? Well, PicoPixel will export this. Let me just save it real fast. And we'll call this bullet. And yeah, that's neat. So save it. We'll export it as a PNG. And we end up with our version of it, which is right here, not that. Okay, so yeah, it should be, no, of course I saved it in the other directory. Let me just copy that over. So that is here in the graphics. Oh, no, PicoPixel's saving it somewhere else. Where are you saving this? Oh, I saved it into the sample found pictures. That source material. Right. So, yeah, there's Bullet. All right, let's get Bullet over here to extra Bitboi graphics. All right, so if we look here, yeah, okay, now it's here. All right, so we have bullet.png, and we need this to end up in our ROM. So, and yes, thank you, Nightshade Dude, I appreciate it. All right, so we got to basically pack it. Now, I've been doing that mostly by hand, and I think I have Java installed, so we can probably just look at it here. Yeah. I got to give it all sorts of magic stuff, but huh, that's weird. It used to work. Well, anyway, it's the same picture. So the issue we have is that this is not in the format we need. So what I've got here is this is the tiles, and here I basically loaded a bunch of the front graphics. So we could actually build a loader, but you know, this is Bitboi here in raw form. And the way this kind of functions, this is like, these are all 8x8. So this is 8x8, this is the sprite front, and this is sort of the sprite back. And if you put corresponding pixels together, like the top left from both of these, then that's your 2 bits of color. So this is color from the palette 0, 0 versus, you know, something like this, which is going to be 0, 1. And that's kind of how you get your multi-bit color. So I don't have something that just directly takes a PNG and spits this out. That would be something we could do in Python, I suppose. But anyway, I'll just quickly eyeball it because this is pretty easy. And plus this one's only black and white. So we'll just spell out the binary. So there's nothing on the first line. And let's see, this, oh, there's 8 of these, right? So, and then we have these two. Put this window over here. I have to keep whipping my head around. All right, so yeah. So then there's this part of, actually, you know what? You could see this too. You don't have to believe me. Except the only problem is that the browser usually, like, you know, when you expand it in the browser, it you know, kind of does like interpolation to figure out what to make, you know, to anti-alias it, but that's exactly what we don't want. We want the raw bits in our case. But so this will be, well, here, I'll just do it here. So this thing, and we look at the bullet. Oh, right, but we can't see it because reasons. That's annoying. Yeah, it's black, and I mean, we'd have to give it a background and put it on a web page. So, all right, anyway, this will take 2 seconds, so I'll just do this. Okay, so it's got the 2 dots. Oh, wait, no, off by 1. It's got these 2 dots, and then this one, this one, this one. That's kind of the bottom of the note, and that line is repeated. And then, see, you can kind of see the drawing here with the ones. And then this comes all the way through. And oops, these 2. And we skip that one, and these 3. Okay, so that kind of, you can kind of see the note there. Okay, and then since this is just, we're gonna have an issue with that color, but we'll worry about color later. So I'll just make this white. So we'll just copy it. So 2, I think on the current palette I have 2. If both bits are active, then it's selected as white. All right, so let's try that. Let's rebuild our ROM and load up the emulator. Okay, now if we come and look in here under PPU viewer, then we get a new window. And in that new window, we can go and see, look at this. Looks pretty good. Yeah, just ignore all these mono errors you'll see from messing. All right, so that looks kind of like a note. So this is the current tile map that you can see. So I just pulled the text is just from Cc65. It's the one that's built into the their standard Nes lib. I shortened it because they had it like doubled for some reason. They had inverted and regular, you know, so they could do. It was really like text mode console seemed to be like the main app that they had in mind. It doesn't have the full ASCII set. It's just kind of a bunch of the ASCII set, and then the control characters are obviously missing. And this is what I'm using to build the attract screen. Is this sort of checkerboard here. And there's some ANSI line drawing characters, box drawing characters, and then, yeah, it's sort of normal. This part is normal ASCII, and it maps nicely. So anyway, here I've got Bitboi left and right, and I've got the, and we've got our bullet here. Now, I notice on him, I made the background all white. And I wonder if that's going to be an issue because I think it's set as transparent. But anyway, let's just put this in the game and sort of see what happens. All right, so if not, I can change the color and just slap red on one of them. Blue. Okay. So we'll just, yeah, let's do that. Let's put this somewhere in the scene. So right now we've already got the bullet code. So in the shot fired, I'm saying if the shot's fired, then show that sprite last. So right now it's tied to sprite number 1, but as you just saw in the table, let's go back to our table, which is under our PPU viewer. It is right here, which is sprite tile index 82. All right, so let's kill Messin and rebuild and run. So we come in here and we shoot. Hey, we have a music note. Nice. All right, Bitboi's getting advanced here. It's fun. It seems way quicker when you're over here. All right, cool. So, yeah, let's. Well, we have a million features to write, so we got to write them. I mean, I like having the scenes, but we kind of have to give Bitboi something to stand on, and that's going to get into the gravity. So, yeah, let's do that. So I think, yeah, we'll close this, and I can close this. Yeah, thanks, Fafi. Really, the messy part there was getting the library to compile in the first place. But all right. So I think to do so, we need to have a way of drawing the level. We don't want to take up all of the RAM necessary to just. I mean, we could just make an entire bitmap in memory of the full level, which if we packed it wouldn't be too bad. But I feel like that's not a good move. I mean, so I'm already using up a lot of memory for the attract screen. So I think it's probably a bad move. I mean, we could procedurally generate the level. I mean, so just looking at our source material here, this is kind of what we're after sort of next is this platform. So we should probably just start with a simple across platform like this so that there's a bottom of the world to fall on. And then we can start getting into how we want to arrange the memory to store this stuff. All right, so what I'm drawing there, when I'm loading the level, I'm assuming that we're probably not going to redraw that. So I'm putting it, so for the NES, you have like the sprites, which are sort of on top, and that's where we just added the bullet sprite. And then you have the name table, which is kind of behind. And well, the name table literally has all the sprites. The name table hardware is usually where the background of the level goes. So in the case of Mario, that's like, the plants that you see in the background and the ground that Mario's running on. So the name table is kind of the right place to put this stuff. Now, we fortunately don't have to deal with scrolling because of the way this game is designed. Like it's all one scene. Now, it's using this sort of like different levels. So we're going to have to worry about gravity, and we're going to have to worry about jumping, and we're going to have to worry about hit collisions. So if you jump and you actually land on this platform, we need to do that. And then the door, I'm not worried about. That's just a counter. So we'll count that down to 0. When it's 0, we'll change the sprite, and then that could be in the name table too. we don't need to burn sprites. We have to be really careful with sprites because in any one scan line across, you can only have 8 sprites. And I'm already going to use 2 for Bitboi, a third one for the bullet. So that only leaves 5 monster sprites. And that's assuming I have nothing else that's moving on the screen. Now, he does have some other stuff. Like he's got these bullets. So we could just, I mean, they're not bullets, they're keys. They're bits, but they're not necessarily on the same line. So we could just add the restriction that you can only fit however many more, up to like 2 or something on a line, and then we don't have to worry about the sprite hardware. Okay, so let's go after just getting a line here for the floor. So I started doing something like that. I hadn't really made my mind up. Yeah, to do generate the floor. So let's not have the floor move sort of how I was doing this. So nice thing about load level is it's only called once, because when I actually call load level, I'm resetting it so that it matches the new level. So I just started saying, well, we're going to have different levels. I mean, but we could just worry about making one level for now. Okay, so I'm cheating here and I'm turning the PPU off. I also included the code, this is part of it up here, but I included the code. This is based on Shiru's example, where you can update, you can basically wait for the scan line to come all the way down to the bottom. This is the V blank area, and you can redraw the name table when you're in this area before the scan line returns to the top. So this is sort of that trick. I'm not going to go into too much detail about how that works, but for now, I'm okay just loading the level once because we're only going to blanket when we're moving between levels. So we can turn the PPU off, but we do need to know how we're going to arrange memory. So here I'm just setting it to the start of the name table, and then we're just filling it in with all zeros. So I could change that, right? I mean, we could make this all ones, and then we'll get a very busy scene. So yeah. It's a nice busy scene. And some interesting artifact here, but probably because I'm blowing out like how much you're allowed to have. But so anyway, that's a full fill. So we're not going to do that. Instead, we're going to fill mostly zeros. So this is basically, there's 32 tiles across and then there's 32 tiles down, but that includes the V blank area at the bottom. So let's fill just 28 of these. And then after that, we'll fill the next 32 with a single line. Okay, so I kind of guessed where the V blank was. So we can even bring that up one more. So let's take this to, we'll fill 27 blank, and then we'll take the last one. Okay, so that's kind of closer to where we currently have Bitboi standing. I'm not sure how much bottom of the world we want to include. I mean, obviously there's some graphics here for the Lego blocks, which is, I think, part of just kind of the normal UI, but we probably don't want to overload it. I mean, the table memory is sort of right once, so we can just come here. Yeah. Okay, we could even fill in that last one too, which will cut a little bit into our V blank, but that should be fine, right? So the neat thing about drawing here is we don't have to worry about timing because we're turning the display off, so we're not racing the beam so much. So we don't have to worry about visual glitching. So we can just sort of draw all we want and then turn the PPU back, re-enable it for the display. Okay, so obviously Bitboi here is still floating, so let's put him onto a multiple of 2. The sprite hardware is not limited to be, so I've been assembling tiles sort of like, 8 by 8, 8 by 8, 8 by 8, 8 by 8, and they're fixed, right? So if I, for example, if I just knock one of those off so that you can see it, like let's say we fill in like 31 here and not do this line, then you can see this is like a missing tile, like over here on the right. So you can only put the name table on tile boundaries. And then what you can do is you can scroll the whole scene. So that's how you get that smooth Mario side scrolling action. You can't place them anywhere other than at an exact tile, name table location, like tile location. So that's kind of integral. But sprites, you can put on any XY place, which is they're such specialized hardware, you don't have that many of them, but you can put them at any interval you want, because that's actually just in screen coordinates, where this is 0, 0, and this is like, 256, 240, or whatever the final dimension is. So we can, let's move this down. So that's the reason why I can do that with the joystick. So like it allows me to precisely position this to like kind of anything that I want. Now, if I look right now, this is actually going to be in the right location that I need. So we can cheat a little bit here and just take a quick look at the PPU, and we can take a look at our sprite. Well, let's take a look at the sprites. So these are the sprites that are active. They're pulled from this is sort of the character ROM. So this is the name table. So these are the ones that I've activated. This is how much I've got left, right? So I've got all of these that I can use up for sprites on the screen. So here's Bitboi as 6. So I'm assuming that it'll be, like we showed before. So I'm burning the memory now. But they also include where they're currently positioned. So you can see this is at 5,199. This is at 5,191. So it looks like that 191, which I guess is 192, I'm probably a pixel off, is where I want to be. So we can come to where that gets placed. These are the schlorps, so we're going to move them in a moment. So this is where you can see, you can finely specify X and Y for sprites, but you can't do that on the name table. You have to use tile numbers. And we're not going to worry about where the shot is relative to where you are. So it's just a matter of us putting our character in the right place. So it's currently starting at 5. We can move that to an interval so that, well, I like leaving it sort of off. And we'll just move this to 192 so we can just take a look. Okay, so what we don't know is if we're off by 1 here. Yeah, we are. Okay, so it really was 191. That's odd. Oh, I guess it starts from 0. It's like, that's weird. Yeah, see, now we're smoothly on top of the world. Standing on something. Okay, there's a little hole in the world. Oh, just hit a schlorp, bad thing. And that's what I was worried about with that sort of transparency. You can see as I cross over there, it's like it's coming through the black. So I don't know if that's like the particular black that I assigned or not. So we can, yeah, the sprite hardware is being kind of clever there. So the palette is here in the data as well. So here I've got 2 palettes that I can work with. So this is the name table palette, and I just chose these colors. So your NES color, yeah, here's the palette. These are all the colors you have to work with. So, and this is kind of their equivalents for anyone who's interested. You can take a look over here at the resource I'm using. So I'm just specifying a color, which is an offset in this thing. So this black is tile 11, so that's kind of like over here, which is showing that it's all 0, 0, 0, but it's something is seeing through. So anyway, let's not worry too much about it now. Let's worry about other things like our invisible bullets. So all right, well, I need to put back that last row. And okay, oh, and I still dropped my last line, so we do need this third one for a fill. Yeah, all right, cool. All right, so we can start adding jump. Now, jump gets into like collision, right? Because we need to know, I guess we can hard code the jump for now, but we need to know like where to return to when we're jumping, or if we've jumped onto another platform. Well, I guess yeah, we should worry more about like how we're going to do the geometry, because that's going to inform like how we jump on things. Oh, I also left the schlorps hanging in midair, so we should fix that. Okay, so this should also be at, now these are just single, I'm using single sprites. I'm thinking we should probably double their size. So we could do this +8, and we could do this +8, and we could do this, and this one is not going to have enough room. So I'm going to move this over to 240, and then we could do this +8. All right. See, you burn those sprites fast. That's why there's not too many. Okay, so this is if we make them just 1 by 2. I think we'll make them square. So that's, I guess, the size of the mushroom troops. All right, so let's make them square. So to do that, we just do this, and we add 8, and we do this, and we add 8. So let's just do this for now. Yeah, okay. So if we position that down, then we should really drop this by 8 pixels. So this, oh, and of course I used the same 192. So this, we're going to need like an array for this. So let's just say that this is unsigned char. And we'll call these the enemies. And we'll make this an array. And this would probably have to be a dynamic array. I think we're going to just say that there's at most 3. And for each one, I'm going to need 2. Well, you know what? I need, so if there's 3 enemies and each one has an X, a Y, and a tile number. I can actually just say that's an enemy type. That way I don't have to specify all of them. Well, then you're going to get into an if statement. Ifs are expensive. So, all right, X, Y, and just, we'll burn another byte. So we need 3 bytes for each one. All right, so 9 bytes, and it's going to look like, yeah, let's so we'll say that this is like enemies. This is, I'm going to pull this up as a global, so we don't really need to pass this around. So we're going to add enemy 0, and we're going to put it at 160, 192. So, and then we're going to have this sort of do our work for us. So we don't want the, oh, I don't want to be in here. So let's add an enemy. add enemy. And that needs to have a enemy number. And we can get away with this at setup times. I'm not too worried about like the stack access. The stack is like a little bit slow, so that's where you want to use the globals as much as possible. We'll assume that the compiler's optimizing, which it isn't doing that much optimization. So Cc65 is a fairly non-optimizing compiler. So yeah, this will do like, let's see. So let's just say number, which is, everything's just going to be a char because it's a byte. And then we're going to say the, I guess we'll call this offset. And then after the offset, we're going to need to know the X and the Y. And I forgot the tile. Well, so we're going to let add enemy do that. I'm just going to hard code a single enemy type, but we would also add something like the enemy type there. All right, so if we do add enemy and the enemy array is available, and so it's going to be enemies on offset. And let's arrange this as X, Y, and tile. So 0, which should be just the thing, will be X. We can make this a preprocessor macro, I guess, later. Y would be this plus 1, and this plus 2. And we could actually just rip through that. The index register would, we can look at how it assembles, but we could use the index register to just kind of like rip through that. And this we'll stick the tile in, and it's going to be, oh yeah, that's going to be kind of messy, isn't it? So, because right now I have them all as the same tile type, which isn't really the case, because it's going to be like, this is 40, that's 41, 40, 40, 42, 43. So we're going to burn 4 tile locations. Yeah. So yeah. So I guess the conditionals, I mean, if we want to save memory, then we're going to end up using a conditional then. Yeah, that's not a big deal. I'm not that worried about it. I mean, we'll go with that. Oh, the glass is empty. It's not half full. It's just totally empty. All right. And what I'm thinking to do with this is we could get rid of all these. Yeah, see, I want to sort of map from like an enemy descriptor to a set of sprites. So this should really be a type, right? Because this is going to be a set of what it's going to do when it gets to it. So yeah, I don't really need this function at all, do I? All right. We basically want this to kind of rip through the array when it gets here. So let's assume for the moment that enemies is set up correctly. So you know what? I want to skip this. I don't really like how this one's going. But let's just say that this looks like 192, 192, 40. Yeah, see, I can't do that. And 216, 92, and this will be I'm actually gonna move this one just so that I can find to replace that later. And this will still be the same enemy type. And, but you know what? For now, let's deal with the problem we have. We'll worry about that problem later. So let's just worry about where these things are located. And then the third one is going to be 240 and 192. All right, cool. So, oh, really? So shout out for the intelligent sort. Let me, you know, I don't have the bot up. She was, so I don't know, Green Hell. Is that the same game as the trees, Among Trees or something? Among the Forest? I forgot the name of it, but like I was watching her play it the other night and it looked just brutal. Yeah, that was bad. She just got like gored by a bear like nothing. Okay, so that should work now. Yay. Actually, she has a short command, doesn't she? Yeah. What are we doing? Shout out for her. Yeah, that's like just a rough game. Funny thing is, she wants to do Nintendo. She's doing C programming right now, and she wants to do NES coding. So this is, yeah. This is a brutal game. I'm going to play this brutal game for now. So we're not going to worry about this. And this, we're just basically going to rip through everything that's there. So let's just say, I hope I didn't use I, but I guess we'll get a compiler warning. I sometimes global I just because I know I'm going to need a lot of counter. A lot of counter cases, but anyway. All right, looks like no. So I is less than enemies. And we'll do that. And so let's say enemies sub. Actually, you know, we're going to need 2 arrays for this because we got to do some, double loop. Because first we need to just, well, let's just put them in the top left corner for now. So I'll say that this thing is, we're going to need to maintain which sprite we're on. And then we're going to need to say like, okay, this thing sub this thing. So if I'm going to go an element at a time, then I need to do this by the amount of memory because there's 3 of them. And this needs to go up by 3s. And so OEM sprite that thing. No, that's, see, because then you have to do it like one at a time. Yeah, all right, that's silly. Well, it's fine. All right, so this thing, and we'll just always make it OX40. You know what? I want to see them be different. So let's use printable characters. I think. Actually, this is already a printable character, so we could just add in I here. All right. So that'll run 3 times, and it's going to take the offsets that I set before and probably break. Because I'm probably off on one of these numbers, so let's find out. Yeah, okay. It doesn't look like 107. Oh, right. This is an older version of C. So you can't add a variable in the middle of your routine. Like all variable declarations have to be up at the top of whatever your routine is. So let's do this thing, which is I. And you know what? That's no good. Because this is going to add it every time it loops around. Oh, that's okay. I'm just overwriting it, so it doesn't really matter. All right, so we can get away with not initializing it later because we initialized it up front. So we can just do nothing and do that. Now, I know multiply is expensive, but theoretically we could actually just, we could do this. Should have computed it ahead of time. I don't know how much like constant folding happens on this compiler, but let's keep this pure so that we make mistakes later with our code. All right, so 9. And I need to pass in sprite. Okay, so this is the offset that we're going to use. Huh? Too few. What am I missing? X, Y, tile. Oh. Send her to lurk on Zork's stream. I guess that's an option. Okay, and something bad happened. So that's fun. Oh yeah, she is. Okay, yeah, green hell. That is that. Guess they renamed it. All right, so this thing, we got our first one and then sort of things didn't work. So let's trace through, what did I do to this? So enemies has to do with my loop. Hey, what's up, Brandon CC? How you doing? It has been a while. You come back for some NES here, huh? Because I'm not going up by 3s anymore. Ah, sad face. Which we could just call 1, because 1 is 1, whether it's in hex or not, so. All right, let's fix our Nintendo game. Yay, all right. I mean, if she wants to learn 6502. Yeah, no, I think Nightshade Dude, I think she's more curious because she's been working hard to learn C programming and she's interested in doing like something kind of game related. And I was like, yeah, I'll be working on a Nintendo thing. And she's like, really? In C? And I was like, it'll be, you know, C and assembly, but, you know, a fair bit of C. So yeah, NES is, it's definitely a harder architecture. There's some pretty good dev, like, I mean, like Messin makes this a lot easier than it used to be. I mean, you can really inspect like so much stuff about what's going on with, like, you know, you can look into memory, which oh yeah, you do get to see it. So this is actually memory cycling. So I've got some frame counters in here and some other stuff. And that's it. That's all of memory. It just mirrors. So yeah, it's a different time, you know. It's really a console from a very different era. And we have musical notes that are shooting now. All right, so we can mess around with our monsters a little bit now that we have a way to do that. So I'm gonna just bump this up so that it places this and it places +8 version of it, and it places not +8 version of it. But so we're gonna make this into a box of whatever symbol was chosen. And that minus a little bit of math, actually, well, here it's, these are, oh no, I is going to stay constant. Okay, so we should be fine there. All right, so we'll just cancel this and do that. Yeah, look at that. All right, so our slurps now have a little bit more depth. Let's bring this down so that they're actually on the ground now that we have a ground. And now that we have a way to do that easily, we can just, this is what I was hoping to do earlier. We can take that 192, we can add 8 to it and realize it's 200. All right, so if we run that, hey, now we're shooting over their heads too, so we're gonna have a hit collision issue, but we can move down the point where the bullet comes out, I think, and then we don't have to worry too much about the collision. So the shot is this thing, so that's X and Y, and our issue is that this basically gets set up when the shot gets fired, and it's just taking this and it's adding 18. I was playing around with the fact that this could be anywhere because it's in the sprite hardware. You're burning sprite hardware for it, so you get fine-grained XY. So we can just move the level down a little bit. So let's just move it to like, I don't know, 7, 6. So it should still intercept, but, oh. Huh, that's not quite right. Yeah, this starts the shot being fired. Wherever the sprite is. Oh, that's kind of weird. That's because we have too many sprites on the line now. See, so I can only shoot when they're not in the same line. That's why it's cutting off the note. See, it disappears when I'm... Oh, see, now that's the Nintendo. Yeah. Now it's... Yeah, now it's really like the arcane hardware. This is why you don't want to burn sprites. So, is this Pokemon? Look, you can collect them. See, we're gonna collect them. You can collect them. Okay. Wow, that's really fun that that's getting clipped. All right, so, all right, I think the short fix for right now is we just won't double them up on the line. So we can say these things will be 8 by 16. So this is kind of why I wanted to test this with like everything filled out, because, you know, you don't know what you're going to get into, right? So we've got like the 2, 3, 4, 5, 6, 7, 8. That's it. So I put the bullet on there and we're out of sprites. So, and that's part of why I drew the bullet last, because we want to know that now before I go burning it and, you know, clipping the wires on the prom and everything else. All right. So let's just drop, for now, let's drop the second one. So that'll leave us enough sprites for the line. We could just switch to 2 enemies, which would be fine too. And we can also do some cycle timing. Yeah, okay, so now we get our full shot. Trevor's going to be upset when I tell him that the cats can only be 1 high and two high and one across. So that's yeah, I don't really want to cut Bitboi because yeah, that's a bummer. Well, so it's either that or we just cut the number of sprites. So let's cut the number of enemies in a line. So that's fine. We can put more enemies up above so that they're on different lines. You know, by the way, you might notice that from Super Mario. Enemies above, enemies below. Okay. So let's cut this to 2. So each one is 3. So let's say that you only get 2 enemies now. And we're going to cut the third one. By the way, I can get rid of this. So this one, yeah, we'll put those back. So this will give us the, yeah, I mean, no, this is really that, isn't it? Let's go step at a time, right? So this is really this one plus 8, and this is really this one plus 8. Okay. So that'll give us back to 4, but now we still have too many. Number of enemies is now 3, so let's try that. There's too many initializers. Oh, so 2 times 3. Oh, because I didn't cut the last one. Yeah, compiler's checking for us. Okay, so I can fire a bullet because I have 1, 2, 3, 4, 5, 6, 7 for the bullet. We're okay. I'll save 8 for doing the split scroll trick, so we're okay. All right, so that's it. That works. Nice. Nice, simple NES programming, right? Everything's kind of a little challenging. Well, it's really hot up here tonight. I'm just gonna complain about it. So I think I'm gonna call it. I was gonna go a little bit later, but it's just super hot. AC's on the fritz today. So I want to thank everybody for dropping by. I think that Nightshade Dude's asking, is it 7 or 8 sprites per line? I'm pretty sure you get 8 sprites per line. So we'd have to go look at the. It's just that you usually burn one for the scroll trick. So I actually, did it say on the other page? I always forget. Yeah, I forget where it says it. It's somewhere on NesDev that I just read this earlier today. But there's a sprite. Yeah, sprite 0 is the trick, by the way. So. Oh, you know what? I think I read it in Shiro's notes. That was. Let's take a look in the library. So I think it's in OEM SPR. No, it's not showing up here. Yeah, so you set the, no, it doesn't say here. I read it somewhere. I think it's 8 per line, and the thing is that you almost always save 1 for the split scroll trick, and you don't know if it's gonna be on that line or not. So like 7 in reality. I'd have to go double check, but I think that's true. Don't quote me on it. Oh, here's the OEM. Yeah, you get up to 64 sprites total. We're using 8x8 sprites. You can configure 8x16. Then we have to rebuild the linker file and all sorts of other fun stuff. Yeah, I don't see it in here. It's somewhere in the docs. Yeah, it's gonna annoy me. The OAM this is the sprite hardware, basically. Yeah, this is if you try to cycle time it for the line. Yeah, I don't know. It's here somewhere. This is really a great website, by the way. Yeah, see, everyone, yeah, Sprite 0 is kind of a special sprite. Special sprite. Special sprite. Okay, yeah, this actually shows you the whole timing. Yeah, it's super detailed. So they've really mapped this thing out at this point. So I want to say that's true. Not 100% sure. Like, no need to read. Yeah, it's definitely hot in here. Let's go take a look and see if Enceladus is still streaming, because it might be fun to raid her. Or we could go see if Trevor's on too. I guess that would be. I mean, we are building this thing for Trevor. So. And I'm getting an ad. It looks like she's going. Yeah, let's see what else we got. All right, yeah, let's go raid her. All right, well, thanks everybody for dropping by. I appreciate it. I think, yeah, I'll clean that stuff up and probably move ahead for the next stream, so that some of this, there's a lot of like busy work to get any of this to work. So anyway, I'll see you all with the ad for those of you coming over for the raid, and yeah, have fun tonight.